Okay. So the topic of today's TED Talk is test-driven development. Okay, and so basically, what we'll cover is everybody has heard of test-driven development in one form or the other. Some of us practice it. Some of us have read it about in the forums. Some of us have read about it through our managers and heard about it through our managers and all, but everybody has little bit or some idea about test-driven development. So today when we cover this topic, I'll explain in detail what is test-driven development, how do we approach it, we as a team, how do we approach it, and few things. Okay, so the contents of the tech talk would be a brief introduction to test-driven development, what not essentially prerequisites, but what all you should be having or what all you should already be doing in order to facilitate test-driven development, because test-driven development has its own development process. So you have to have some things ready with yourself so that you could do TDD. Then what are the benefits of test-driven development, and what are we as a team doing to follow test-driven development process. And then I'll also cover an example which will be a very simple example, so that the people who are very new to TDD would have a better understanding of it. And then I'll cover a few shortcomings or limitations or few things which are not really covered by TDD to a larger extent. Okay. I'll also have a very small slide about behavior-driven development, which is sort of an extension to test-driven development, and then we'll take questions if any. Okay. Okay. So before I introduce you to TDD, I would take some time to first of all explain what is a unit test basically. Okay. TDD is basically a sort of an extension to unit testing. Okay. I've just started. Okay. So TDD is basically an extension to unit testing. So why are unit tests important for a developer? Okay. So first of all, when a developer is writing a unit test, it forces the developer to think. Okay. Think about the testing perspective of the code. So what exactly he's going to write, and think about the functional scenarios in a more detail rather than just jumping to the code. Okay. And so another advantage of unit testing is that if you are detecting bugs at unit testing stage, the cost of fixing a defect is a lot lesser than when the same defect is identified at a later stage in the release cycle. So it's always better if you identify a defect in the earlier stages of the release cycle. Okay. And if you have unit test cases for your module or your program, then refactoring that program becomes a lot more easier, because you obviously have that confidence that if my test cases are passing, that means whatever refactoring I have done is correct. There's no issue with the refactoring. And another aspect of unit tests is that unit tests should be very granular in nature. They should not cover a big functionality or anything as such. They should cover very small portions of the functionality. There are multiple benefits to it. Primarily, if unit tests are granular in nature, they are simpler to write, and if they are failing, you know where exactly it's failing. You don't have to scan through a big class or a big use case to actually figure out that okay, my unit tests are failing here. Okay. I'll come to that. Okay. So that was regarding unit tests in general, and now what is TDD? What is the concept of TDD? What does TDD entail for a developer basically? Okay. TDD is basically test-driven development. So that goes without saying that you write the tests first. Okay. Before you start writing your code, you will write your tests first. Okay. So basically, instead of starting directly starting writing functional code, you would first write the code to test, and then you'll write the code as a afterthought to the testing code that you have written, okay, to the test that you have written, okay. And you do it in very small steps, okay. It's not like you write a big your big test suite first and then you start writing. You start writing a small test which will test a very small part of the functionality. You'll write that test and then you'll write the code for that test, okay. So that is how you'll go. So a normal this thing is that you would not write a test for more than 5 to 10 minutes and a corresponding code for not more than 5 to 10 minutes. Every 5 to 10 minutes you switch between writing a test and writing a code, writing a test and writing a code, okay. So that is normally how it's done, okay. And you will not write a new code if there isn't any test failing for it, okay. If you get a defect in the system and anything like that, you will not just start writing the code to fix that defect. First of all, you have to write a test which will fail because of that defect, and then you'll fix that test basically. So no new code is written until there is a corresponding test which has failed, okay. And then TDD also says that you write very simple code to start. You write a simple test and then you write a simple code to basically fix that test, okay. And obviously, as I said, you write the code only to fix a failing test, okay. And when I say you write simple code, obviously since you have a test which is already there for the code, you can always go back and refactor that code so that your test is already there, and then once the test passes, as I said, once the test passes, you are confident that your refactoring is perfectly fine, okay. And this brief concept of TDD, there are 3 rules of TDD as explained by a guy called Robert Martin. He's a lot more into this agile kind of software development. So what he says is that you are not allowed to write any production code until it is to make a failing unit test pass, okay. Until unless there is a failing unit test, you will not write any code, okay. That's the first rule. And okay, you are not getting it, okay. Just so that's the first rule. You are not allowed to write any production code unless it is to make a failing unit test pass, okay. And you are not allowed to write any more code. I mean, once you have a failing unit test and you are writing code to fix that unit test, you will not write anything more than what is required to make that test pass. So you will not cover any more conditions, any more functional scenarios, nothing. Whatever the test is failing, you'll just fix that much, okay. And obviously, so you are not allowed to write any more production code than it is sufficient to pass one unit test, okay. And obviously, if there is a compilation failure or even the method does not exist, you are writing a code, you are writing a test, and that method itself is not there, that will give a compilation error because the method is not there. So that is also counted as a failure only. So that's very clear on that. Okay, so continuing on the introduction, what's the primary goal of TDD? Okay, the primary goal of TDD is that you should think about your requirements and design before you start coding, okay. And you have to first have a very clear mind about the requirements that are there and what design you are going to follow. So as I said earlier, that TDD and unit testing as a whole, that forces a developer to think, okay. And then the primary goal of TDD is that you write a clean code that works, okay. A basic thing is that you already have a test for that code, okay. So and the key concept is that you write simple code, okay. So basically you already have a test, and that is there for the corresponding code that you will write. So you will write a clean code and obviously it will work because your test will pass, okay. Then when you are refactoring a code using TDD, if a test fails, then you just undo your code. So right now your all tests are passed, okay. Now you are doing some refactoring of your code. So you after just 10 minutes you did some changes, and then obviously if there is any error, your test will fail. So what you do, you don't start debugging why the test has failed. What you do is you just undo it till the time you reach till the stage wherein the tests were passing, and then you start redoing it. Okay, so this saves a lot of time in debugging. You don't need to debug a lot. You just have to undo. So that's the benefit of a shorter testing cycle. You test you test so frequently that at any time your tests are failing, you know, because it's because of the changes that I did in the last 5 or 10 minutes. Okay, so that significantly removes the effort of debugging. Okay, yeah, I say that write your own tests rather write your own code. So if you talk about a normal development cycle wherein, let's take something which is not TDD, what guys do is they write their code and then they write their unit test, if at all they write their unit test. Okay, so in that case also what normally people say that the developer who has written the code should write the tests. Okay, but here what I'm saying is it's TDD, so your tests are written first and then your code is written. So the person who is writing the test, obviously he should be the person who should be writing the code. They should be the same person. Okay, and then if you have a test suite which has been developed over a period of time using TDD, these tests should run very fast. Okay, because these tests will be run frequently, and no developer will wait for let's say you write 10 minutes, for 10 minutes you've written a test or written a code. No one will wait for another 10 minutes to just see the test run. The test should run in in seconds. Basically you press a button, you do something here and there, and the test should run and give you the results right there, because that reduces the waiting time for the developer. Okay, it should not be like he should be starting a server and doing some bunch of stuff to just make the test run. The response should be very fast. Okay. Okay, so this is a flow chart basically. So what concepts I've just explained, this is sort of a flow chart which depicts that concept in a sense. Okay, so what it says is you write a test. Okay, you start with writing a test. That's the first thing. You create a project. You'll not even create your code class file. You'll first write. You just identify what class you will class name, and you write a class name test file first. Okay, and then you identify what method you are going to write, and you write that test method first. Okay, so exactly. So as I said, you'll write a test, and if there's nothing, there's no action, there's no corresponding code for it, it will fail obviously. If there's nothing, it will fail with a compiler error. Okay, then you see that if the test fails, then if the test fails, then you write the code to make that test pass. Okay, and then you run all the tests, and if the test again fails, then you write the code to correct that test, and once all the tests pass, then you write more tests, and then you go and that's how you go about it. Okay, you will not write any code until there is a test failing for that code. Okay, so this is basically a simple flow chart depicting that. So that was the introduction to test driven development basically, and now I'll cover some of the prerequisites for test driven development. Basically these are what I think should be there in order to take maximum advantage out of TDD. Okay, because TDD is obviously an extra thing that you are doing. You are writing your test first and then you are developing your code. So these things should be there to make it more easier to do TDD. Okay. First of all, the first point is true for any unit testing framework. Your test suite should have access to the code it's testing. Otherwise, it just cannot test your code. So if your actual code is encapsulated and the APIs are hidden, it can't really test it. So the primary thing is that your test suite and your code should be part of the same project basically, so that your test suite has access to your code. Okay, that is the primary thing. So obviously unit tests are written in the same project in which the code is there which is being tested. Okay, the projects are essentially the same. Even in your IDs etc., the projects are basically the same. If by chance you're using a database to run your unit test, there is some dependency on the database which should be minimal ideally, but if let's say it is there, the the strategy that you should use is that you should clean your database snapshot before running your test. Okay, but if you are starting to run your test, your database should be in a clean state, because when your tests will run, they will put some data, they'll update some data, they'll insert some data, they'll do some things here and there. Okay, so ideally once you start your test, your database should be cleaned up and then your test should start. Rather than, so there's another theory to it, that once I do my tests, once I finish my test, then I clean it up. What I'm saying is you clean it up before starting your test. There's another theory which says that you clean it up after finishing your test. The difference is that if you clean it up after finishing your tests, just in case some tests have failed, you will not be able to figure out, because the database will be restored to a clean state. Okay, so the thing is that before starting your test, you clean up your database, and once your tests have run, whatever data that has been created will be there already in the database, and you can easily debug it. Okay, and as I've explained, tests should run fast. They should run very fast. I mean, take for example, if a class, if you're writing tests for a class, and let's say this class is also big, then also it should not take more than a minute. A minute is too much. Okay, it should finish in under a minute. You write your code, you write your test, you run it, and it should be there. The failure, the success, everything should come within that much time. Okay, and so in order to ensure that your tests run fast, there should be minimal dependency on things like database, file system, networks, etc. Because these are the factors which tend to slow down your program. Unit tests are basically programs only. Okay, so these are the factors which would slow down your results that come from the unit test. Okay, and then your test should be very simple, as I explained earlier. Your test should be very simple, because if your tests your tests are failing, you should be able to exactly pinpoint wherein it's failing. The place wherein the test is failing, it should be very easier to find. You should not have to debug your test again to find out where the code exactly is failing. It should be that simple. Okay, because one of the benefits of TDD is that your debugging time is reduced. Okay, and another prerequisite that I think is that no separate configuration should be required to run a test. Okay, whatever is there in your project, if I take that project, I put in some other machine, some other system, anywhere, it should run directly. It should run. Okay, I should not be setting a variable here, a system variable there, and bunch of stuff like that. It should be more and more independent of the configuration. Okay, I directly put my program anywhere. Obviously, the whole project needs to be taken, but once I do that, it should run. There should not be any issues there. Okay. That's basically a set of prerequisites. More importantly, your test should run fast. That is the primary goal. Everything just follows it. Okay, because it's a very small time frame in which you shift from coding to testing, and if your tests don't run fast, the whole objective is defeated. Okay. Now we'll jump on to the benefits of TDD. What all benefits are there? And so, as I have already mentioned, that it forces the development to think about the requirement and design it properly. Since your first concern is testing the functionality rather than developing it, so you are very clear about the requirements, what needs to be there. Okay, before you start writing your code to implement that, you are very clear about it, and then you start writing your tests. And so when I say TDD, obviously it means I write tests and I write code. So that essentially means I write more code. Overall, both things are still program. So effectively that means I have to write more program. So does it mean I have to spend more time? So that's the primary concern that people have, that if I'm using TDD, I'm writing a lot of code. Okay, because a program might be small, but the tests, the unit tests to test that program would run into lot many methods, much more than what the program actually is, because that's basically TDD. But so does that mean that I would have to spend more time writing my functionality or writing my program? Well, it's a bit true, because you actually write more code. You write more and more lines of code. Let's put it that way. You write more lines of code, so it will take you more time. But it reduces the number of defects in the code. and it's very clear that if there are defects in the system for a longer time, the time that it takes to resolve them at a later stage is much more than the time that it's taken to resolve it right at the point of inception, wherein the developer is writing a code, and if you are able to find out defects right then and there, it's much easier to fix. It's very less process overhead, resource overhead, everything is minimal. You just find a defect, your test fails, you find a defect, you fix it right then and there. There's nothing more involved in that. Okay, so as I said, it enables you to capture your bugs very early in the development cycle. And obviously the frequent nature of testing, you're testing very frequently while you're developing, and this leads to you're able to eliminate defects very early in the process, and this avoids you from the lengthy and tedious debugging that will need to be done. If the defect was found later in the development cycle, you would have to do a lot of debugging, and if it's the case that the bug has been found on the customer side and stuff like that, then the debugging takes forever to do, because then you will need the logs and stuff like that. So basically TDD, yeah, more code will be written, more lines of code will be written for TDD, but it will help you in capturing defects much earlier in the system. Okay, and so as I said, TDD means you write simple code and you write your test first. Okay, so basically when doing this, TDD leads to a more modularized, flexible and extensible code, and obviously testable code, because testing is the first thing that you are doing. So your code is obviously testable, and it leads to a modularized code, because in order to make your code testable, it has to be modularized in certain sense, so that your test classes are able to access it. And it means that the developers think software in small terms of unit that can be written and tested independently, and obviously that can be integrated together later. Okay, and software is loosely coupled and easily maintainable. Okay, so it tends to be better designed once you are using TDD, because it's very loosely coupled with the different systems that are there. Okay, different functionalities that are there, and it's very easily maintainable because it's in small units, so it's very easily maintainable, and obviously you have the test to help you with the maintenance. Okay. Okay, so more on the benefits of test-driven development. So the first thing that definitely comes out very well is that you have 100% code coverage. Okay, since you're writing tests first, and obviously you're writing code to pass that test, you have 100% code coverage. There's literally no line of code, or no leave alone a function. There's no line of code which is not tested. Every code, starting from your business logic to your exception handling to your error handling, everything is everything is covered with your test cases. Okay, primarily because no code is written until you have a test which is failing for it. Okay, and let's take a scenario wherein you already have a perfectly working system, all your tests are passing, all your code is there, and then somebody identifies a defect, because defects, let's say defects are there. There's some defect which is under some weird condition. What you'll not start fixing that defect first. You will write a test case which will rather identify the defect for you. That test case will exactly find it out that okay, this is a scenario that is failing. So that is basically your failing test case. Once you get your failing test case, you write a code that will fix that test case. Okay, so this way any defect fixing you are also doing, that's also enhancing your test suite or your test bed. Okay, and so it's also a regression safety net. It helps a lot in minimizing regression. How? Let's take the earlier example that you had a defect. Now you have done fix at one point. Okay, that one concern test which you have written, which you failed because of that bug, that test has passed now. But then you have a whole suite of tests which are running. Okay, so that suite will identify that any other functionality has been broken because of your new code change or not. So it automatically, it's a regression safety net for you. It helps prevent regression right at the developer's end. Okay, and obviously you run the whole test suite. If there are any issues that are found, then again you have a failing test which you need to fix, then again that cycle continues. Okay. So as I said, TDD enables you to catch the defects much early in the development cycle, and so you have tests which cover 100% of your code, so it gives you a lot of confidence while refactoring. And this is one of the big advantages of TDD, because most of the times, I would say almost 100% of the times, a code that is written afresh has some or the other scope of refactoring. Okay, some or the other scope of refactoring is there, but most of the times developers would refrain from refactoring, saying that it's still working, so why do I need to refactor? Because if I refactor it, it might induce some defects in the system, something might crash here and there. But if your code is developed using TDD, you will have that confidence of refactoring the code at any point. Okay, because your tests run fast. You can start at any point of time. You can start, okay, let me refactor the test. I'll not refactor the whole method, I'll just refactor a small part of it. I can still do that because I have that confidence that my tests are running. I don't have to dedicate a week for refactoring. I will say, okay, today I'll do some refactoring. I did some refactoring and my tests are passing, I'm happy with it. Okay, so that it gives you the confidence to refactor the code. Okay, and another big advantage for developers basically is the TDD method. In the TDD methodology is that test cases serve as a working example for the code that is there. Okay, so let's take for example any new team member has joined the team, and you want him to work on something, and the code is there. Okay, the code that is running is there, but if someone wants to find out that how should I be able to use the code, what kind of objects are passed to it, what kind of lists are passed to it, if talk about Java terminologies. So you have a working example for that test for that code, because your test cases are nothing but examples. Your test case will contain exactly what all objects are passed to that method. It will contain exactly how the parameters are passed to that method, what the method is actually doing. So test cases are basically working examples for the team and any new team member that joins. Okay, and documentation. So everybody, I mean most of the developers would agree that no developer goes and looks for the documentation on a wiki or on a doc file or on a PDF file or on a site. No, if you have a project code sitting in front of you, you will not go look anywhere. You will start with the code only. You start looking at the code and try to understand what it's doing. So in this case, your test cases are of a lot of help, because once you start looking at the test cases, you have a very clear idea of what the code is doing, because the test cases are supposed to test that code. So once you read through a test case, and test cases are much more elaborate than code basically, because they cover a lot more scenarios. Obviously the code is executing all those scenarios, but they cover all those in lot more detail. So test cases are basically, they are working specifications of your functional code in effect. Okay, and so they form a good part of your technical documentation. And another sort of let's say a disadvantage of documentation on a wiki or on a web on a doc file is that if some functionality has changed, someone has to go and manually update it, and but ideally that should be done that should be very judiciously followed, but in lot many cases that is not followed that very judiciously. The documentation always lags in terms of the functionality gets implemented, and documentation is just following it up in most of cases. Whereas if you talk about your tests, the tests are automatically updated documentation, because if you are adding a new functionality, you will have to write a test first for that functionality. So automatically the documentation, the test case is automatically updated even before the functionality is implemented. Okay, so that way it's very helpful for the developers, because that is something that we can understand to in a much more in a better way rather, and obviously in a much more detailed way. Okay, so that was with the benefits of test driven development. I'll take some time to tell what kind of approach we as a team follow to test driven development. Okay, So what we basically do is, as I explained, that you have to think your functionality or your requirement in terms of smaller chunks. Okay, so as I said, whenever we take any functionality or any user story, as we call it, for example, then we break it down into simpler ones, so that a developer who is working on it has a very clear idea of what that part of story is doing. Okay, and so as I explained, so it's simpler to implement, and when people are working on simpler user stories, simpler functionalities, let's say, and it can be integrated later, and you obviously have your test suite which is for that small functionality, and finally if the whole test suite runs, you have a working code basically. Okay, and in our case, we minimize the database interaction. So as I earlier explained, that if there is database interaction in your test suite, that will basically slow down your test, because that's the time taken for the for the database updates to happen. So it will slow down your test, and obviously you will need a container, and you need all those things. You'll need a server also. So we try to minimize that. We more or less we try. It's not there, but well, in few places that is there anyways. So we minimize that using mock objects. So basically there are few frameworks available which through which you can create a mock object, which is basically that it's not when you fire a query on the database, it gets you some data, and you're not actually firing a query on the database. You are stimulating that, and you are getting a mock object, and you can use that mock object. So in effect, you don't actually go to the database to get the data. You don't actually go to the database to get the data, but you are using a mock object instead. So that in turn helps you in running your tests very fast. Okay, and as I said, because of this, there is no dependency on the database, and if there is no dependency on the database, your tests will run faster. Okay, and more on that. So as I said, your tests should run fast. It should be right there at the developer's discretion to run the test. You should not be going to a system and configuring a run or something like that. So to facilitate that, first of all, the unit tests we write, and I think I forgot to mention, we use JUnit to write the unit tests. Okay, the unit tests we write are directly runnable from your IDE. In the Eclipse, you just click on that button, or you do Alt Shift X and T. The test will be run for you right then and there. Okay, you don't have to switch anywhere. You're coding, you're doing programming on your IDE. You can run your test from your IDE. You fix your test on your IDE. You write your code in your IDE. Everything is right then and there. You don't have to switch to any other workspace, any other machine, anything like that. So basically that is a very fast way, and it's obviously very convenient for a developer. Okay, because quite frankly, a developer would be much more comfortable working in an IDE than with a batch file or an XML file or an AND file and anything like that. Okay, then this is from the developers at developers end, and then obviously we have a continuous integration setup wherein the whole test suite, whatever the whole test bed is run on every commit, on every change that goes into our Subversion system. All the tests are run, and any failure that is there, or the status of all the tests is reported in real time to all the developers that are there in the team. Okay, so this basically, just in case anything misses out from the developers, and it's caught right then and there. It does not go to the next day rather. Okay, then there is this thing that unit tests are basically nothing but another class which tests one class. Okay, so if there are private methods in your code, how will you test it using unit tests, because it's not available to the other class. So in our team, what we do is we rely on the fact that the private methods are anyways called by at least one or the other of the public methods. If nobody is calling that private method, then there's no point of that method being there. So it's anyways called from one or the other methods. So we test that method, and we ensure that in turn the code coverage is there for the private method also. Okay, so that is one approach that we take. because there's a lot of debate. If you read through the forum, there's some debate that goes on that how do you test private methods, or do you actually write tests for private methods? Because you can write using reflection and all, using inner classes and all, you can actually write tests for private methods, but we don't do that. We ensure we rely on the fact that the public method will be tested properly and the code coverage is there for the private methods as well. That's how we ensure it. Okay, so these I've rather in detail I've covered what are the benefits of test driven development and what all it entails, what all you should be doing, how you should be doing to some extent. Okay, now I'll take one small example, a very simple example. I've kept it very simple. A small example that will demonstrate how do you start writing a TDD program. Let's say how do you start doing that. Okay, so and basically if you read about TDD, you will find this kind of a term, that red green refactor. Okay, you'll find this kind of a term a lot many places. This basically means as you write a failing test case, it will give you red. Okay, once you run the test case in an IDE or something, it will show you red. You change your code, or you put your code to pass the test, it will give you green. And as I said, you write a very simple test case and you write a very simple code. Then if you want to refactor your code, you can still refactor your code because you have a running passing test case for it. Okay, so that this theory I'll explain in detail in the subsequent slides. Okay, so I have a very simple requirement that I want to copy a file from C drive to D drive. Okay, very simple. Okay, and so I've identified that I would need a class called attachment. I would need a method called writeAttachment. Okay, as simple as that. So I create a project in my IDE. Let's say Eclipse. I create a project called attachment module, and I create, as I said, you'll write test first. I've not even written the class which will do my actual copying of the files. I'll write the test case first. Okay, so I'm using JUnit here. So I write a simple class which says attachment test, which extends test case, and I'll execute this class. Okay, I'll execute it because it's a test case. It will execute. Okay, and it'll give you an error that saying that there's no test that is found in attachment because there is no test at all here. Okay, so this this is how start. This is my first red flag. Okay, it's there. Now what I'll do is, okay, I hope it's visible. Okay, now what I'll do is that I'll write a test method. Okay, I'll write test method which so I have identified that there will be a writeAttachment method. So I'll write a simple test saying that test writeAttachment, and I'll just instantiate my actual class. Okay, I'll just do simple this much. Now this test case or this code, they both don't do anything. They are not doing anything, but still this test case is logically correct, and because it satisfies everything that is there, everything is fine, so it will pass. It will pass, and okay, so now I'll start writing tests for the actual functionality. Okay, so what I do is I create a new file object, and I call my writeAttachment method, and I put an assert that since I'm copying from a C drive to a D drive and the file I've passed is this, it should check whether the new file has been copied to the D drive or not. So that's a simple assert that is there. So it will just check that that the file is copied, the test has passed or not, and here so I've written this, and then I write my simple method wherein currently I have not put any logic. I've just said that okay, my method name is writeAttachment, and I have not yet thought of the logic. I'll just say return null. Okay, nothing's there, and my test case is already there. So what my test case will do, it will fail. It will say that a file was expected, but nothing was there. The file was there's no logic to do it, so the return was null. So then I'll start about writing the actual code for copying the file. Okay, then I'll write the actual code for copying the file. I'll use my input streams, I'll use my output streams, I'll write it to a buffer, and then finally I'll do my stuff. Okay, I'll write the actual code which will make that test pass. Okay, so now once I've done this, I'll just run the code and it will come out green. Okay, because there is a test case and there is a corresponding code which does all that. Okay, so you will notice I've kept it very simple. I've not used any complex logic or anything as such. I've kept it very simple, that you write a test case, a simple test case, a simple method, and once the test fails you write your code. Once the test passes you are done. Okay, now let's take it to another level. Okay, now your first test case and the corresponding code is done. Okay, we have written a small program using TDD and whatever the functionality was required we have achieved it. Now let's say you get another enhancement to that functionality which says that instead of copying one single file you copy a list of files. Okay, you copy a list of files. Now obviously your signatures to the method will change, a bunch of things will change here and there, your logic will change. So how do you start approaching this? So what you will do is, if you see my code is as it is. Okay, what I've done is I've changed my test case. Okay, what I've done is instead of one file I have, let's say, 3 files now. Okay, I have 3 files which I've added to a list, and now I would want my writeAttachment method to take a list of files and return me a list of files saying that these are the files that were asked to be copied, and these are the list of copied files. Okay, now if I do this, my test case is more or less complete, and but if I run this it will give me an error saying that there is a writeAttachment method which is there in the attachment class that accepts argument as a file, and it's not applicable for arguments which is a list of files. So it will give me this error because my test case has changed and my code is not there. The code to actually pass the test case is not currently there. Okay, so now I'll go about refactoring my code. Okay, so I have a failing test case. Now I can start writing my code. Okay, so what I do is I change my logic, I put a loop, I do this and that, and it looks like that this is good enough to make my test pass. Okay, once I'm sure about that I can run it and it will pass. Okay, so this is a very simple small example through which I've demonstrated how to write code using TDD. Okay, it's very simple, and you will have a lot more complex examples when you are actually doing stuff, but this explains the philosophy and the process when you are doing test driven development. Okay, now that's basically your refactoring has been successfully completed. There was change in the requirement and you refactored your code to complete that enhancement. Okay, and now you would notice that since it's a very simple test, it's a very simple thing. Right now you would think that a lot more things can be done. The test case can be enhanced, the code itself can be enhanced. So now you can do all that because you can do all the changes in your code because you already have a test which will check it out for you and which will ensure that your code is proper. Okay, so this way refactoring you can do much more confidently because there's already a test which will test it out for you. Okay, so this was a very trivial example to explain test driven development. Okay, so up till now what I've explained what are the benefits of test driven development, a brief introduction to test driven development, what kind of stuff you should be doing if you are doing test driven development and everything. But if you read around about test driven development, you will find there's a lot of resistance to following test driven development because many people here also you don't follow test driven development because this development process has been there for a long time. Okay, it has been there at least for what, 8-9 years. So not much people follow test driven development, and when it's having so many benefits, why is there a resistance to follow test driven development? So primarily what I think is that there is resistance to change. There is a development methodology that is already set, that you get your requirements, you write the code to implement that requirement, you do some sort of unit testing. If at all you do some unit testing, you make a release, the QA comes back to you saying these are the defects, and then that's how normally people do it. That's a normal SDLC cycle. So that is one thing, that there's a resistance to change. And second thing is there's a cost of transition. The cost of transition, as in what basically TDD entails is that you change your whole development mindset. The whole mindset of a developer has to be changed, so that you don't think about the code until and unless you have written the test. Okay, that the change in that mindset is also a threshold that people find it difficult to cross. And then many of us think that it takes too much time. It's because you have to write tests and you have to write more and more tests, and believe me, the number of tests, the number of tests that would be there for a small functionality would be a lot more than the functionality itself. So you have to do simply too much tests need to be written just for a simple piece of code. Okay, let me put that way. So the people think that it takes a lot of time. It's just an overhead. And then another thing with the developer's perspective is that developers just hate to write tests. Okay, if you ask any developer to do a testing, to write a test case, let it be on a test case on a JUnit kind of framework or in an Excel or anywhere, if you ask a developer to write a test, they would not like it that much. So but TDD says that you have to write tests before writing your code. That's even more what do you say, bothering for a developer. Okay, so that is also one of the reasons that that is there. And then there's one more mentality, rather, that if you give any requirement to a developer, the first thing that comes in mind is that developer starts to analyze that requirement and think that how will I actually implement it. That is the first thing that any developer psyche, most of the developer psyche, that is the first thing that will come to them, is that how do I fix this, how do I fix this defect, or how do I implement this functionality, and stuff like that. So that is one thing. So if I say that no, you cannot think about all that, you have to first write a test case for it, so that automatically goes against the thought process of a developer. Okay, and then some people think that their design can handle everything and they don't need a test suite or a test bed to do that, which is absolutely rubbish in that sense. But so these are some points which sort of people argue about, or people would argue about, rather, that they are not following TDD. And in many cases people have not actually followed TDD, and they still are saying that there is a resistance to follow TDD. They don't like TDD in that sense. Okay, so that is what it is. So that was regarding all the benefits of TDD and a little bit about the resistance to adopting TDD. Despite obviously TDD is a great, it's a very nice development process and has a lot of advantages. There are few shortcomings here and there which should not be bothering to anyone, I would say, but there are a few shortcomings which I found I should bring to notice. It's basically the same person is writing the test and same person is writing the code. Okay, so if that guy has not thought about some scenario, so that scenario he will not test for it, and obviously he will not code for it. So his code still has 100% test coverage, but that some scenario might be missing in some cases. Okay, so that is one sort of a shortcoming or a limitation of TDD. Okay, which can be definitely overcome using a review cycle and anything like that. Okay, and then one more thing is that TDD, the test suite, let's say that a test suite developed using TDD, it's not an alternative to integration testing. So integration testing is, when I say TDD, I'm very much clear that it should be unit tests. It should not be test scenarios or integration level tests or anything. They should be plain and simple granular level unit tests that should be written by the developer, and then the corresponding code should be written. It's not an alternative to integration testing. Okay, because integration testing is altogether a different thing, and you should use a separate automation and something like that to actually do it. It should not be done using TDD is not for that. Okay, that's very clear. Then if you have badly written tests which still cover your functionality more or less, but if they are not very well written, there are hard coded strings here and there and few examples like that here and there, and that becomes an overhead, because then you have to, because the your test suite is a huge piece of code. Okay, it's much bigger than your actual program. That will always happen. It's much bigger than your actual code, so they become an overhead and you'll have to clean them up. And basically, so the problem that one more problem that comes here is that if one test case is badly written, it does not and it's failing, then one would just go and have a look and say that no, this test case can be ignored, the failure of this test case can be ignored. That is the worst thing that you can do. When you're saying the failure can be ignored, then a lot of other things, when they're failing, you're just sort of ignoring them, saying that okay, these are fragile test cases, and wherein there might be an actual defect there, but you're ignoring just by saying that these are fragile test cases, and we'll revamp them at some point later in time. So badly written test cases can become an overhead, and that is true for anything, not just test cases, any code that you write, anything. That is true for almost anything. Okay, and then obviously if at any point of time you have a test case failure that is there, so as I said, it's a developer's responsibility, rather, that once you're writing any test and you're writing corresponding code, you have to run those tests and see whether anything is failing or not. But let's just say it has left the developer's machine and it has gone into your repository, and obviously if there is any test case that is failing, it has to be taken on priority and it has to be fixed. So that is not basically a shortcoming, it is something that you have to do. It's something that should be done. Your test case failure should not, no test should fail when you're doing any kind of development methodology, let it be TDD or anything else. Okay. Okay, so that was basically about TDD and most of the things around it. Then I'll take some time to explain about BDD, which is sort of an extension to TDD, more or less. So TDD is mostly about the developer that is writing the test and writing the code, whereas BDD is it takes a larger audience into picture, and it basically encourages collaboration between the development team, the QA team, and the business team, which is the requirements from it. So basically in BDD you actually don't start with writing Java or any writing tests in any programming language. You basically write your tests in a natural language, as if you're writing in English. You just write in English basically. So they are basically called stories. Okay, they are not called tests because they are not tests as of now. They're just stories. You write your requirement in the form of stories. So since it's in a plain natural English language, anybody can write it. It's not a program. Anybody can write it. Your requirements team can write it. Your QA can write it. Anybody can write it. Okay, a developer can also write it, obviously. So anybody can write it in a simple English, and then once that is there, then you use that to convert it to a test case. Okay, so BDD goes one step further in a sense that it's actually a documentation in English, and apart from the developer can understand the programming language as well. So I had explained that the unit tests form the perfect documentation for a developer. Okay, but in case of BDD, that documentation is extended to the QA guys and the business guys also, because they are written in normal English language. Okay, so in this case, it's a sort of a approach to unit testing, because a developer, let's say a developer will write the stories in BDD. You don't call it unit tests, you call it stories. Okay, we'll write the story, and that story can be forwarded, and obviously the test cases are written based on that story, and the code is also written based on the test cases. Everything is sort of in line with that story that is written, and that story can be given to the client, to the customer, and that forms a sort of a thing for acceptance testing. because you know this is the story that is there, and the actual development is on the basis of this story. So you already know. So that is also called ATDD, which is acceptance test driven development. Okay, that's also one more name for BDD. So as I explained that you write your tests in a natural English language. Now there's a tool called JBehave. Okay, which is basically JBehave, as I mentioned, it's a tool. So basically it tells you that you should write in this form of English. I mean, you should use these keywords rather. So what it does is actually convert it takes your story, your English story which is written in English, and it converts it to a test case also. So it does a few things here and there. So that is the basic use of JBehave. So this I've just covered as an extension to TDD. We are not doing it currently, but this covers a broader group in terms of when you're using behavior driven development. It covers a broader group rather than just the developers. Okay, that is pretty much it. Are there any questions? I would like to take them. Okay. I think there are no questions. So well, that was pretty much it on the topic of test driven development, and thanks a lot for watching the webinar. If there are any questions that you find later on, you can always contact me at amishra@digit.com. And thanks a lot everyone.